Pluto is a faraway, elusive, and less conspicuous planet that was once considered part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario be possible, and what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable 32 seconds phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later redefined as a dwarf planet, continues to be a subject of fascination and study within the vast universe. Recent speculations from leading experts suggest that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to warn of the possibility of 0:01 and 3 seconds AM catastrophic encounter between these two celestial bodies, which could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete one full orbit, and since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, the intrigue doesn't end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the 1 minute and 35 seconds nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. Its orbit is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is the way it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying the 2 minutes and 9 seconds conventional expectation of their relative positions in the solar system. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets, whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. The puzzle deepened when it became 2 minutes and 40 seconds clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem, in space. Understanding how three objects, Pluto, Neptune, and the Sun, interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. The stability of all planets' orbits is ensured by the concept of non-concurrent libration. In 3 minutes and 12 seconds, the case of Pluto and Neptune, this means that whenever Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 degrees apart. This spatial separation prevents a collision between them. Another contributing factor is orbital precession, which refers to the slow vertical movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. 3 minutes and 43 seconds additional factor at play is the VSK wobbling, a concept named after three researchers, Vashkov, Slyuta, and Krivov, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable over long periods. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. The VSK wobbling shows that even in the most unpredictable environments, there are 4 minutes and 17 seconds underlying patterns and forces that maintain stability. This three-body problem is crucial to understanding the nature of Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the stabilizing forces at play, is actually quite erratic. Small deviations in its initial conditions could lead to significant differences in its path over centuries. Nevertheless, these simulations also showed that 4 minutes and 49 seconds Pluto's orbit maintains stability over incredibly long timescales, millions or even billions of years. To fully grasp the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets, like Neptune, Jupiter, and Saturn. Neptune's influence is significant, as it governs Pluto's orbit in a special resonance. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This gravitational resonance helps keep Pluto's orbit stable. But Neptune is not. 5 minutes and 23 seconds the only player in this complex equation. Jupiter's massive gravity also plays a key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces working together ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from Neptune's influence. Without these stabilizing forces, the solar system would be much more chaotic, with planets potentially colliding or being ejected from their orbits, triggering catastrophic consequences across the 5 minutes and 53 seconds solar system. And so on. The ongoing study of Pluto, Neptune, and the outer solar system remains a crucial aspect of modern astrophysics, offering insights into the forces that govern our cosmic neighborhood. However, as we push the boundaries of our knowledge, new questions continue to arise. One of the most intriguing possibilities is the influence of yet undiscovered celestial objects. The hypothetical Planet 9, a massive body thought to be lurking in the distant reaches of the solar system, could have a profound effect on the orbital dynamics of Pluto and Neptune. If such a planet exists, its gravitational pull could subtly alter the trajectories of these outer worlds, potentially shifting Pluto's stable resonance and introducing new uncertainties into its future path. While Planet 9 remains elusive, some astronomers believe that evidence of its presence could be found in the strange, elongated orbits of trans-Neptunian objects. If this unseen force is real, it could change our understanding of the delicate balance that has prevented catastrophic collisions in the past. Could it be possible that an external gravitational disturbance might one day break Pluto and Neptune's harmonic cycle, setting them on a collision course after all? 16 minutes and 30 seconds. For now, simulations suggest that Pluto will remain safely locked in its resonance with Neptune for millions, if not billions, of years. Yet, even the most advanced numerical models are unable to predict the universe's future with absolute certainty. The chaotic nature of celestial mechanics means that even small, unaccounted-for perturbations could set off a chain reaction of orbital shifts. Beyond Neptune and Pluto, the broader Kuiper Belt, a vast region of icy bodies at the solar system's edge, may also hold hidden influences over planetary orbits. As new Kuiper Belt objects, KBOs, are discovered, astronomers continue to refine their models of how these distant worlds interact. Some even suggest that a major collision within the Kuiper Belt itself could send a shockwave through the orbital alignments of outer planets, leading to unexpected consequences. Could such an event occur within the next few million years? If so, how might it affect the orbits of Pluto, Neptune, and the entire solar system? 17 minutes and 15 seconds. As we look ahead, one thing remains certain: the cosmos is in a constant state of flux. Planets migrate, orbits shift, and gravitational forces weave an ever-changing tapestry of celestial motion. While the odds of a Pluto-Neptune collision remain slim under current models, the story of our solar system is far from over. With future space missions, improved telescopes, and enhanced computational models, we may one day uncover secrets that completely change our understanding of planetary dynamics. Perhaps a new force, an unseen influence lurking in the shadows of deep space, will one day emerge, rewriting the narrative of Pluto and Neptune's cosmic dance. For now, we watch. We calculate. We explore. The mystery of Pluto's orbit continues, reminding us that even in the vast emptiness of space, nothing is ever truly still. Despite the stabilizing forces at play, the outer solar system remains a realm of unpredictable movements and hidden influences. Scientists continue to debate whether the delicate balance that keeps Pluto and Neptune from colliding will persist indefinitely or if unknown factors might one day disrupt it. One of the biggest uncertainties in this cosmic puzzle is the influence of passing stars. Over millions of years, the solar system drifts through the galaxy, occasionally encountering other stellar bodies. A close approach from a rogue star or a passing dwarf galaxy could exert just enough gravitational force to subtly alter the orbits of Neptune, Pluto, and countless other distant objects. Even a minor shift in the resonance between Pluto and Neptune could send ripples through the solar system, potentially increasing the chances of a collision. Could such an event already be in motion, unseen and undetected by our current instruments? 18 minutes and 30 seconds. Adding to the intrigue, some astrophysicists speculate about the possibility of dark matter playing a role in the outer solar system. While dark matter remains one of the greatest mysteries in modern physics, some theories suggest it could form subtle gravitational anomalies in space, slightly tugging on planets and altering their long-term trajectories. If dark matter concentrations exist in the Kuiper belt or beyond, they could have an imperceptible yet cumulative effect on planetary orbits over millions of years. Meanwhile, a team of astronomers using next-generation telescopes has recently reported anomalous deviations in Pluto's path, tiny, nearly undetectable variations that defy current models. Some believe these fluctuations could be explained by previously undiscovered Kuiper belt objects, while others suggest an unseen force is at play. Could this be evidence of Planet 9, or perhaps an entirely new celestial phenomenon? 19 minutes and 15 seconds. As scientists race to gather more data, space agencies are considering launching a new probe to Pluto, one equipped with cutting-edge instruments designed to map its orbit with unprecedented precision. If successful, this mission could help determine whether Pluto's trajectory is truly stable or if it is subtly shifting toward an uncertain fate. But as humanity stares into the void, the universe continues its slow, unfathomable dance. The cosmic forces governing Pluto's fate have been in motion for billions of years, far longer than human civilization has existed. And yet, in the grand timeline of the cosmos, even the mightiest planets are mere travelers, moving along invisible highways of gravity. Will Pluto and Neptune maintain their ancient harmony, or is an unseen force already reshaping their destinies? Only time, and the universe itself, will reveal the answer. 20 minutes. End of transmission.